Earth's growing population creates issues impacting our health, our global consumption patterns, and our need for specific resources. We're talking about water, power, and disease. Chemical engineers will be responsible for improving the quality of life on Earth by solving these issues. What will they be doing? What might we see? Let's begin with today. The year is 2008. Earth's population is continuing to rise. Although its rate of increase is now slowing, there are still global challenges that occur due to overcrowding and poor usage of resources. As time progresses, the technology that we have developed thus far will be incompatible with the problems soon to arise. The need for change is evident. Chemical engineers must rise to the challenge. Innovation in the areas of water purification, power production, and disease management are necessary. Ironically, each problem we solve increases our global standard of living and brings a new issue to light. Today, we face an energy crisis. Green technologies, developed in part by chemical engineers, are emerging. When implemented on a large scale, they will solve the crisis. Slowly, though surely, they will take ground. (2028). When we think of chemical engineering 20 years from now, we have to consider what that world will look like. Sustainability will be the watchword of the next generation of engineers. In many ways, this will represent the fulfillment of our green revolution. Environmental consciousness and economic pressure will provide the push to shift from a strained, carbon-based energy system to a number of sustainable renewables. Technologies that represent a small fraction of modern power generation, wind, solar, geothermal, and nuclear, can be expected to grow from mere novelties to their full potential. Chemical engineers can provide leading roles in the design, implementation, and improvement of these technologies. Sustainability will change the way we think about chemical processing. Already, its effects are being felt, but in 20 years, green chemistry will become commonplace, challenging engineers with finding new and innovative solutions. Those employed in healthcare will have need for new methods of drug delivery, as well as ever more complex pharmaceuticals to combat drug-resistant diseases. Tissue engineering and other regenerative technologies will become even more effective and widespread. The maturation of emerging technologies will be a central theme of the next decade, and chemical engineers will be vital in making this revolution a reality. (2058). As we approach the middle of this century, our understanding of genetics, coupled with advanced knowledge of heavy metal manipulation, drives the next jump in the ways chemical engineers interact with the world. In the past, most molecules were painstakingly assembled by coupled reaction after coupled reaction, each with its own myriad of sensitivities and nuances. Now, the ability to not only read but understand the mechanics of DNA paves the way to mass bioassembly of molecules. Computers become powerful enough to design the metabolic pathways necessary in custom-designed monocellular organisms to improve product yields an order of magnitude over the large-scale industrial plants of old. In addition, as population growth stabilizes, living standards rise around the world, and green energies become predominant, the focus of chemical engineers turns to the next great challenge: waste management. Improved separation technologies ranging from plasma separation to heavy metal recovery to custom-designed waste processing organisms cause a revolution in global waste management. The age-old dream of turning worthless trash into not just gold, but its component parts becomes a reality. Water purification techniques advance by leaps and bounds. Engineered organisms and advanced waste purification and recovery will form the seed for new market-disrupting technologies, paving the way for humanity to not only live more healthily, but also to truly and cheaply restore the Earth marred by centuries of waste. 2200. As we advance further in time, our biochemical achievements lead to the ability to manipulate individual atoms with precision. The reliable nanoscale robot, built from biological roots, takes hold. Chemical engineers become responsible for adapting the robots to serve tasks as varied as breaking down hazardous waste and administering medicine to targeted sites. Chemical engineers also design and implement the safe replication processes for these machines. Of prime importance will be guarding humankind against the increasingly virulent diseases which have adapted over time to our current defenses. Advances in viral profiling coupled with our newfound nanobots will allow us to combat multi-drug resistant bugs with precision and reduce the side effects of medicines. The capacity to repair our aging bodies and target specific age-related mutations in our genes allows us to live healthier, longer lives. Chemical engineers work with medical professionals to make this technology ubiquitous. The increased lifespan leaves Earth with too high a population and too few resources, and we are forced to look towards the final frontier for water, rare elements, and new places to explore. We ask, where might we find chemical engineers on this end of the millennia? Around the hydrocarbon-rich moon of Titan, operating distillation columns that take advantage of controllable gravity gradients to better fractionate material for manufacturing? On a manufacturing platform that uses zero-gravity conditions to create pure, crystalline products? Managing off-world colonies' air purity and environmental conditions? Perhaps still on Earth, using their knowledge of biology, chemistry, and physics to find a way to improve life for all of us.